If you thought the moon revolves around the Earth without changing its trajectory and would continue to do so for millennia, you'll be disappointed to learn that this is not the case. Since 1969, when NASA installed reflective panels on the lunar surface during the Apollo missions, we have been able to see our natural satellite gradually moving away from the planet. Since then, laser beams launched from Earth have allowed us to precisely calculate the annual rate at which the moon is moving away from us. Hey guys, welcome back to our channel. Today we are going to talk about the moon is getting away from us every year. So let's dig right in. The moon. Our moon moves distinctly, inexorably farther away from Earth each year. Just a tiny bit, about 1.5 inches, a nearly imperceptible change. There's no stopping this slow ebb, no turning back the clock. Gravity forces are invisible and unshakable, and no matter what we do or how we feel about them, they will continue to push the moon along. We will continue to drift apart over many millions of years. The moon was once closer. The moon was formed about 4.5 billion years ago, molded out of rocky debris floating around Earth, and it orbited the planet 10 times closer than it does today. Scientists believe the debris was caused by a collision between Earth and a mysterious Mars-sized object. The moon was hot and molten, glowing red in the night sky, fresh from the cosmic oven. According to scientists, the moon was moving away from Earth at a rate of about 8 inches per year at the time. First scientist to discover this movement. Edmund Halley was the first scientist to identify this peculiarity almost 300 years ago. He was able to make this conclusion through reviewing the records of historical eclipses and was the first scientist to notice this oddity. It is believed that tidal friction in the seas is responsible for this receding, as it slows down the Earth's rotational speed and compensates for the associated loss of angular momentum in the acceleration of the moon, which causes the moon to move further and further away. In order to learn more about the history of the moon, researchers from the universities of Utrecht and Geneva have developed and utilized a number of different methodologies. The recession of the moon has been investigated on multiple occasions. In addition to the numerous hypotheses, there have been some recent breakthroughs. Recent signals were discovered in more ancient rock layers on the planet Earth. Relationship between sediments and Milankovitch cycles. Some of the gorges in the breathtaking Karijini National Park, which is located in Western Australia, cut through strata that are 2.5 billion years old and stack in a rhythmic pattern. These sediments are called banded iron formations, and they are made up of separate layers of iron and silica-rich minerals. They were previously widely deposited on the ocean floor, but now they may be found on the oldest regions of the Earth's crust. Cliff exposures at Joffre Falls demonstrate how strata of a reddish-brown iron formation slightly under 1 meter thick are exchanged at regular intervals with darker, narrower horizons. The darker intervals are made up of a softer form of rock that is more prone to erosion than the surrounding areas. A further in-depth examination of the outcrops indicates the existence of an additional regular variation on a scale smaller than the larger one. Rock surfaces that have been polished by seasonal river water flowing through the canyon reveal a pattern of alternating white, reddish, and bluish-gray layers. This pattern may be seen on the rock surfaces. In 1972, an Australian geologist by the name of A.F. Trendall posed the question of the genesis of the many sizes of cyclical, repetitive patterns that are seen in these ancient rock layers. He hypothesized that the patterns might have some connection to previous variations in climate that were brought about by the so-called Milankovitch cycles. Cyclical climate changes. The Milankovitch cycles describe how small, periodic changes in the shape of the Earth's orbit and the orientation of its axis affect the distribution of sunlight received by Earth over long periods of time. At the moment, the dominant Milankovitch cycles change every 400,000, 100,000, 41,000, and 21,000 years. Over long time periods, these variations have a strong influence on our climate. The occurrence of extreme cold or warm periods, as well as wetter or drier regional climate conditions, are key examples of the influence of Milankovitch climate forcing in the past. These climate changes have had a significant impact on the conditions at the Earth's surface, such as lake size. They account for the periodic greening of the Saharan desert and low oxygen levels in the deep ocean. Milankovitch cycles have also influenced flora and fauna migration and evolution, including our own species. And the signatures of these changes can be read in sedimentary rocks via cyclical changes. The climatic precession cycle. The frequency of one of the Milankovitch cycles, known as the climatic precession cycle, has a direct correlation with the distance that exists between the Earth and the Moon. This cycle is caused by the precessional motion, wobble, of the Earth's spin axis, also known as the changing orientation of the spin axis through time. This cycle has been going on for approximately 21,000 years, but in the past, when the Moon was located far closer to Earth, its lifespan would have been significantly shorter. This means that if we can first find Milankovitch cycles in old sediments and then find a signal of the Earth's wobble and establish its period, we will be able to estimate the distance between the Earth and the Moon at the time that the sediments were deposited. This is because Milankovitch cycles can be found in sediments that are millions of years old. Previous work of scientists suggested that Milankovitch cycles might be maintained in an old banded iron formation in South Africa, lending support to Trendel's theory in the process. Around 2.5 billion years ago, the banded iron formations that can be seen in Australia were most likely deposited in the same ocean as the rocks that can be found in South Africa. However, the cichlid fluctuations in the rocks of Australia are more easily observed, which enables scientists to investigate the variations at a level of resolution previously unattainable. According to the findings of the study of the Australian banded iron formation, the rocks include various scales of cyclical variations that approximately repeat every 4 and 33 inches, 10 and 85 centimeters intervals. We found that these cyclical variations occurred approximately every 11,000 years and 100,000 years when we combined these thicknesses with the rate at which the sediments were formed. This led us to conclude that these variations were caused by natural processes. According to the findings of the research, the 11,000-year cycle that was found in the rocks is most likely associated with the climatic precession cycle, which has a duration that is far shorter than the present 21,000 years. After that, scientists were able to determine the distance that once separated the Earth and the Moon 2.46 billion years ago by using the precession signal. Here we came to the conclusion that the Moon was approximately 37,280 miles, 60,000 kilometers, closer to the Earth back then. That distance is about 1.5 times the circumference of Earth. This would make the length of a day significantly shorter than it is at the moment, bringing it down to approximately 17 hours from the current length of 24 hours. How would lunar remoteness affect the Earth? To begin with, as the Earth's rotational speed decreases, days on Earth will become increasingly longer. Another factor is that winters will be much colder and summers will be much hotter. Tides would be weaker as a result of the Moon's reduced gravitational influence on the planet. Even so, due to the effect of the Sun, they will continue to exist, albeit slightly. According to NASA, sea level rise due to climate change, coupled with the influence of the lunar nodal cycle, will cause a dramatic increase in the amount of flooding by 2030. Understanding solar system dynamics. Astronomical research has provided models for the formation of our solar system, as well as observations of current conditions. Scientists' research represents one of the only ways to obtain real data on the evolution of our solar system, and will be critical for future Earth-Moon models. It's incredible how past solar system dynamics can be deduced from minor variations in ancient sedimentary rocks. However, one important data point does not provide a complete picture of the Earth-Moon system's evolution. Other reliable data and new modeling approaches are now required to trace the evolution of the Moon over time. However, one thing is certain: we should not be concerned about its absence because it will never escape the gravitational pull of the Earth. The Moon and the Earth will eventually reach an equilibrium, and the Moon will stop moving away. So, what do you think about the Moon getting away from the Earth? Let us know your thoughts in the comment section down below. That's all for this video. Please like, subscribe, share, and comment on this video if you enjoy it. Till then, take care. Thanks for watching.